What does the lower interfacial impedance of the HCSBB-Men electrode indicate about the speed of the reaction kinetics between the Na ions and the electrode-electrolyte interface, and how is this related to the efficiency of the electrode? How does the faster reaction kinetics of Na ion diffusion in HCSBB-Men electrode reflect on its electrochemical performance, and what advantages does this provide in energy storage or conversion applications? What insights can be gained by analyzing the Nyquist curve in terms of the differences in impedance between the PBM and HCSBB-Men electrodes? And how does this analysis guide the optimization of electrode materials for specific electrochemical applications? Can Davis-Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is the Nyquist plot, and how is it used to analyze electrochemical systems? How do Nyquist plots of PBM and HCSBB-Men electrodes help in understanding the impedance characteristics of these materials? What information can be extracted from a Nyquist plot in terms of both high-frequency and low-frequency regions? How does the shape of the Nyquist plot indicate the nature of the electrochemical processes occurring in the system? Why is it important to compare the Nyquist plots of PBM and HCSBB-Men electrodes, and what insights can be gained from such a comparison? How do the features of the Nyquist plots of PBM and HCSBB-Men electrodes differ, and what do these differences tell us about the impedance and charge transfer processes in these materials? What role does the high-frequency region of the Nyquist plot play in analyzing the overall impedance of the electrochemical system, and how does it relate to the solution resistance and charge transfer impedance? How can the diameter of the semicircle in the high-frequency region of the Nyquist plot indicate the charge transfer resistance at the interface between the electrode and electrolyte? What does the sloping line in the low-frequency region represent in the Nyquist plot, and how is it related to the diffusion process, such as the Warburg diffusion? How do the Nyquist plots help in determining the kinetic behavior of the electrochemical reaction, and what can be inferred from the shape and size of the semicircle or sloping line? What do the differences in the Nyquist plots of PBM and HCSBBM electrodes suggest about the reaction kinetics and charge transfer processes for each electrode material? How can the comparison of Nyquist plots be used to identify which material has better electrochemical performance or faster reaction kinetics? How does the Nyquist plot provide an effective visual tool for identifying the electrochemical impedance characteristics of PBM and HCSBB-Men? And what can these plots reveal about the efficiency of the electrodes in energy storage or conversion applications?